Okay, welcome back to Electrochemical Cells Part 3. And what we're going to do today is we're going to look at a question that involves working out the order of reactivity of different metals when they're set up into an electrochemical cell based on the potential difference that's generated by the electrochemical cell. Okay, so let's go steadily through this. So what are we actually going to do? We're trying to work out the reactivity of metals by setting up two different cells with different metal electrodes, and then compare the voltages produced by the two chemical cells. So let's look at that again. So what we're going to do is going to work out the reactivity of metals by setting up two different electrochemical cells with different metal electrodes and then compare the voltages produced by the two chemical cells. So if we remember from before, what are we actually going to set up? We're going to set up a circuit that looks like this. We've got a voltmeter there, okay, then it's attached to an electrode here. That would be metal B. Then we've got the other side of the cell here, that's attached to an electrode, that is metal A. Okay, then again into our beaker, just move that onto there, then into our beaker, okay, with our nice meniscus, let's go, and our electrolyte, which will be an aqueous ionic solution, okay, as so. Okay, so there we have it. We've got a voltmeter, metal A, metal B, and metal A has got a different reactivity to metal B, so therefore we know we're going to get a potential difference. Okay, so moving on then, the question will give us some information, and actually what we need to be able to do is understand the question and then apply this information to get the answer. Okay, so let's say the question tells us that if electrode A is less reactive than electrode B, the voltage is positive. Therefore, if electrode A is more reactive than electrode B, the voltage must be negative. So let's look at that again. So the question tells us that if electrode A is less reactive than electrode B, or I should say the metal that makes electrode A is less reactive than the metal that makes electrode B, the voltage is positive, and therefore if electrode A is more reactive than electrode B, the voltage must be negative. Okay, right, then we're given this information. So we're given a table that tells us what electrode A is made from, what electrode B is made from, and then when we put these two electrodes together, the voltage that is produced in volts, obviously. Okay, so let's make electrode A from a lump of iron, and we'll make electrode B from tin. Okay, and then we put them together, and the voltage that we read on the voltmeter says minus 0.30 volts. In a second cell, a completely separate cell, we put some iron, make iron electrode A, we make lead this time electrode B, and this time the voltage reads 0.31, minus 0.31 of a volt. Okay, so there we are. Okay, so that's the information that we're given, and now we've got to work out the order of reactivity of iron, tin and lead. Okay, so the information has told us that the voltage is negative if A is more reactive than electrode B. So let's write that down. So earlier on in the question we were told that the voltage is negative if electrode A is more reactive than electrode B. Okay, therefore from this we can conclude that iron is more reactive than tin and lead, because the voltage for iron and tin equals minus 0.30 volt, and iron and lead equals minus 0.31 of a volt. Okay, so that's the information we've been given. Next thing to think is, then we need to remember that the bigger the size of the voltage, whether that's a negative or a positive voltage, the bigger the difference in the reactivity between the two metals. So let's write that down. So then, remember that the bigger the size of the voltage, whether negative or positive, the bigger the difference in reactivity of the two metals that make up the electrodes. Okay, so in this case 0.31 is bigger than 0.30. Therefore, the difference in the reactivity between iron and lead is bigger than the difference in reactivity between iron and tin. Therefore, we can conclude that iron is more reactive than tin, which is more reactive than lead. Okay, so there we are. Let's just have a look back at the original table now to confirm that we understand exactly how we would interpret that table. Okay, so bring that back in there. There we are. So remember that if electrode A was more reactive than electrode B, then the voltage must be negative. Okay, it's told us that. Okay, so if A is more reactive than B, the voltage is negative. So these voltages are both negative, so electrode A in both cases is more reactive than the electrode in B. So iron is more reactive than tin, and then iron is also more reactive than lead. But then how do we work out which one out of tin and lead is more reactive? Well, then we have to look at the difference in the size of the voltage that's generated in each cell. So when we've got iron and tin, the size of the voltage is 0.30. When we've got iron and lead, the size of the voltage was 0.31. 0.31 is a bigger difference than 0.30. Therefore, we can conclude that iron is more reactive than tin, which is more reactive than lead, because the difference in reactivity between iron and lead is bigger. So if that's higher up the reactivity series, then that must be lower down the reactivity series. So the order of reactivity is iron, tin and lead. Thank you for watching. Don't forget to like and subscribe and hit the bell notification to keep you fully informed. Thank you for watching.